In this video, we'll be discussing geometry, which is the study of the properties of shapes, and we'll start with angles and lines. So let's start with a straight line. We have this straight line, and the sum of angles on a straight line is equal to 180 degrees. You can see this is half of a circle. A full circle is 360 degrees. Therefore, this half of a circle is 180 degrees. If we should divide this angle made on this straight line into two like this, we have that this angle plus this angle is equal to 180 degrees. Even if we divide it into three, we have that, let's say this is angle A, angle B, angle C. So angle A plus B plus C is equal to 180 degrees. No matter how many we divide the angles on a straight line, it's equal to 180 degrees. Now let's look at an example to actually see how this is being done. Now in this example, we are given angle A and this other angle to be 50 degrees. So to find angle A, we are going to say that A plus 50 degrees is equal to 180 degrees. And let's give our reason for saying this. Angles on a straight line. Straight line. Okay, so we subtract 50 from both sides. We have that A is equal to 180 degrees minus 50 degrees. We have that angle A is equal to 130 degrees. So we can see how it's easy to solve. And I like writing the reasons for doing the calculations you do, because it will come handy when we see further theorems under geometry. Now let's consider two lines since we've seen one line. When we have two straight lines intersecting each other, when two straight lines intersect each other, we say that vertically opposite angles are equal. So this is, let's say this is angle A, this is angle B, angle C, and angle D, for example. We'll say that vertically opposite angles are A and C are equal, and then B and D are equal. We are going to say that angle A is equal to angle C, and angle B is equal to angle D. So this is what we call vertically opposite angles. And of course, let's dive into an example. Now in this example, we can see we have 65 degrees here, and we've been asked to find angle B, C, and D. So knowing what we just know now, that vertically opposite angles are equal, we can see that this 65 degrees is vertically opposite to angle C. So we can even start with C. We say that angle C is equal to 65 degrees. And our reason for saying that is vertically opposite angles. Vertically opposite in short, and then angles. Now let's look at this angle B. We see that angle B is sharing a straight line with 65 degrees. We can see that. Did you see this straight line? So this is angles on a straight line. 65 and B are angles on a straight line. So we are going to say that 65 degrees plus angle B is equal to 180 degrees. And our reason is angles on a straight line. Angles on a straight line. So we say that angle B is equal to 180 degrees minus 65 degrees. And we have that angle B is equal to 115 degrees. So since we found angle B, finding D is just easy. We have that B is equal to D, we can see the vertically opposite angles, which is equal to 115. And our reason for saying that B is equal to D is vertically opposite angles. Vertically opposite angles. So we can see having the knowledge of straight lines is actually making these diagrams easy for us to solve the angles in them. Now let's talk about angles at a point. We have that sum of angles at a point is 360 degrees. So when we have a point like this and we have so many lines, so let's say, let me even have another line here. Let's say that this is angle A, angle B, angle C, angle D, E, F, and G. We have that angle A plus B plus C plus D plus E plus F, they are all equal to 360 degrees. And our reason is angles at a point. Now let's quickly look at an example. In this example we have here, we see that we have a point and then we have these lines coming from the point, and we have this is angle E and this is angle E. All this E and E shows that these two angles are equal, and we have this angle here as 310. So to solve this, we have that 310 degrees plus E is equal to 360 degrees. And our reason for saying this is angles at a point. Angles at a point. Now we collect like terms. We have that E plus E is 2E. 2E is equal to 360 degrees minus 310. The 310 comes over to be minus 310. So we have that 360 minus 310 is 50 degrees. So 2E is equal to 50 degrees. We divide both sides by 2. And when we divide both sides by 2, we have that E is equal to 25 degrees. Now looking at this example, we have all this. We can see our point and we can see so many things. You can go ahead, pause the video and try out this challenging question. Okay, so let's solve together now. We have FGH, that's what we are looking for. And then, whenever you see this corner, this square shape on an angle, it means that that angle is equal to 90 degrees. So this is a perpendicular corner, like this line is perpendicular to this line. So this is equal to 90 degrees. Whenever you see this shape, it means that this is equal to 90 degrees. Okay, as this is 90 degrees, so if we should solve alphabetically, we have that FGH. So we solve for F. We can see this straight line. You can see this straight line, that this angle 90 and this angle F are on a straight line. They are angles on a straight line. So we can say that F plus 90 degrees is equal to 180 degrees. And our reason for that is angles on a straight line. Angles on a straight line. So that angle F is equal to 180 degrees on this side, 90 comes over to be minus 90 degrees. Then we have that 180 minus 90 is 90 degrees. We have that angle F is 90 degrees. Now let's look for angle G. Now we can see that, you see this straight line and this straight line. So this part is vertically opposite to this part. Therefore, G plus 28 is equal to 90 degrees. And our reason for saying this is vertically opposite angles. we can now see that it's important for us to have reasons why we do things, because someone else might come around and see this straight line and then say angle F, which is 90, plus angle G plus 28 is equal to 180 degrees. And the reason for saying so is angles on a straight line. So whichever way you see it, you should solve it that way because it's actually correct. And then after doing so, you have to write your own reason. So when you come back to that solution later, you are going to understand why you solved it the way you solved it at the time you solved it. Or if someone else should look at your work, the person should be able to understand, okay, this is why you solved it the way you solved it. Okay, so let me just use vertically opposite angles to solve this. You could use angle on a straight line to solve it and it's all correct. That is just how we saw it. So I'll say that angle G plus 28 degrees is equal to 90 degrees. And I'll say that the reason is vertically opposite angles. Okay, therefore I'll say that G is equal to 90 minus 28. So we have that 90 minus 28 is equal to 62 degrees. Therefore, G is equal to 62 degrees. So this remains angle H. So let's look at the diagram once again. We have that. We can see that we could look at it like a straight line and then add up all these and say it's equal to 180 degrees. Or we could look at this corner and this corner being vertically opposite angles, and then we could now solve it the way we solved here. Or we could look at this other straight line. So you see there are many ways of solving this. That is why it's important for you to always write the reason for showing a mathematical equation you did from your shapes or lines. So I'm going to use vertically opposite angles. So I'm going to say that, or do I use angles on a straight line? Let me use vertically opposite angles. So I'm going to say that angle H plus 41 degrees is equal to angle F. That is, I'm using this angle F. And then my reason is vertically opposite angles. And then I'll now say that H plus 41 is equal to 90. Remember that angle F is 90. So angle H is equal to 90 minus 41, which is equal to 49 degrees. So angle H is 49 degrees. So with this, we can see that the complex shape, in quotes, that we started with has been easy to solve because we know some geometrical theorems concerning lines and angles. Now in the next video, we will be looking at parallel lines and their transversals.